Today we're going to study, today we're going to use a fundamental theorem of calculus to evaluate a definite integral. The fundamental theory says that if the function, the derivative of the function equals little fx, then this, if you can find one antiderivative, then you can use that to evaluate the definite integral. I'm going to introduce a new notation. Okay, this integral called the indefinite integral. Okay, this is going to be defined to be capital Fx plus constant. Okay, and here f prime x is just equal to f of x. So if we, this is a general antiderivative of the function. So this is called indefinite integral. The reason we use the integral symbol to denote the antiderivative is because the above theorem, right? The definite integral of the function is going to be the difference of the values of the antiderivative at the end points. Okay. So we're going to, so integral itself, this is called indefinite integral, is just the antiderivative of the function. Okay. So for example, if we x cubed dx, this is just a general antiderivative of x cubed, right? And we know one of the antiderivative is going to be given by this, and e plus constant. Okay. So that is the answer. Yeah, that is the answer. Okay. And evaluate the integral, right, between the points, and that's one of symbol here without mentioning the antiderivative cannot be found out directly. So you have to express as a sum of a power function. Then you find the antiderivative for each of them. Okay, and a plus constant. Okay. Antiderivative x, 2x is x squared. Okay. Now use that, you can evaluate the definite integral. Okay. For example, the graph, right? The graph y equals x times x minus 2. This is a begin with 0, right? And here's 2. Okay. So what is the area of this region, right? The area of this region, if the area is a, so the integral from 0 to 2 of this function is going to be negative a, okay? Because the region is below the x-axis. So if you are able to evaluate this definite integral, you should get a negative number. Then the area is going to be the absolute value of that number. So it's going to be the antiderivative is this, and evaluate the two endpoints. Okay, so this is going to be 1/3 2 cubed minus 2 squared, and that is going to be 8/3 minus 4, negative 4/3. So negative 8 equals negative 4/3, so the area is going to be 4/3. Okay, we find the area. The next typical problem is a quotient of two functions. evaluate this definite integral. This indefinite integral. So this is general antiderivative of the function inside the integral. It's a quotient. So in order, the only method we have here is the linearity of the integral. So we have to express as a linear combination of power functions. So you get square of x plus 1 over square x dx, right? And each of them is x plus x to the negative half dx. So this is a sum of power functions, right? Only when you express as a sum of power functions, you can easily evaluate the find the antiderivative of each term, then add them together, use the same linear combination. Okay, so it's going to be 1/2 plus 1x to the 1/2 plus 1 here, plus and plus constant. Right, we use the standard formula, right? So it's going to be 2 over 3x 3 over 2 plus 1 over 1/2 is just 1 over 2. Okay, I'm sorry. So this is a okay. So this is antiderivative. And we know, right? We know the derivative of cosine x, right, is going to be negative sine x, right? And derivative of cosine x, sine x is going to be negative. It's going to be cosine x, not negative. Sorry, what's going on here? Yeah, that is going to be cosine x. So the integral of cosine x will be negative cosine x plus constant, and the integral of cosine x is going to be sine x plus constant. Okay. So those are the two basic formulas. Now, so use that. You can find the area of the region bounded by the sine curve from 0 to pi. Right? So y equals sine x. So what is the area of that region, right? So area of that region is going to integral from 0 to pi sine x dx. So entire derivative of cosine x, sine x is negative cosine x. This is the entire derivative, and you evaluate the 2 endpoints. So you negative cosine pi minus negative. Okay. So cosine pi is negative 1. It's a 1. Minus negative 1. It's going to be 2. So it's integer, right? The area under the graph y equals sine x is just equal to 2. But if you know this relationship between area and the integral, so sometimes you just use the area because you can calculate area in a different way to evaluate the integral, right? For example, like integral from 0 to 2 absolute over 2x minus 1 dx. Okay. How do you evaluate this integral? It's absolute value of 2x minus 1. So you have to see where to change the sign. Okay. And draw the graph first. You have to draw the graph first. Okay. So 2x minus 1, absolute value. It is going to be 2x minus 1 if 2x minus 1 greater than or equal to 0. Otherwise, it's going to be negative, right? Negative 2x minus 1 if 2x minus 1 less than or equal to 0. So 2x minus or greater than 0 is going to be x greater than or equal to 1/2, right? Here's x is less than or equal to 1/2. So it's 2x minus 1, 1 minus 2x. So how can I draw the graph? The graph, this is a 1, this is 2, right? This is 1/2. So graph, here's a 1, 2, yeah, it's a 3. It's hard. 1, 2, 3. Okay, so here's 2 and 3. Okay, so when x equal to 1/2, when x equals 0, this is going to be 1. Okay. So this is a graph of the function. And we know the integral is going to be the area of that region, right? Below this. So this just equal to the area of the region, right? The integral of the region under the graph, right? And it consists of, the region consists of 2 triangles. So you don't need to evaluate the integral. You just give me the area if you calculate the area in 2 different ways, right? So it's going to, the first one is 1/2 times 1/2 times 1. The second triangle is going to be 2 minus 1/2 is going to be 3/2. The height is 3. Okay, so that is going to be 1/4 plus 9/4, which is going to be 10/4. It's a 5/2. Now, if you don't want to use the area, how do you evaluate integral? You have to evaluate integral separately. Okay? You still get the same answer. So integral from 0 to 2, 2x minus dx, right? You have to remove the prime absolute value first. So you divide the integral into two areas, 2 regions, 2 intervals. But on each interval, you can determine the sign. For x less than 1/2, 2x minus 1 is negative, so it's going to be 1 minus 2x dx. And here, 2x minus 1 dx. Okay. Then you evaluate, then you find the antiderivative of each function. And you evaluate 2 endpoints. The antiderivative of this function is x minus x squared. And here will be x squared minus x evaluated at 2 endpoints. Okay. And you end up with the same answer, 5/2. Let's look at this. Is going to be 1/2 minus 1/2 squared minus 0. It's okay. And here's 2 squared minus 2 minus 1/2 squared minus 1/2. Okay. So after you simplify it, you will get 1/2 plus 2 minus 2 squared minus 2. Okay. Okay. So that is 1/2 plus 2, which is 5/2, right? 5/2. Did we get 5/2? Yes, 5/2. Great. Okay. So for some function, if you get a very nice graph, and you can calculate the area in different ways, then you don't need to go through all those antiderivatives, using antiderivative to find the evaluate integral. Okay. Here's another problem. Okay, it's 1 plus x squared and the cube. Evaluate this integral. I have to expand it and express it as a polynomial. Okay. So we only can evaluate integral of a polynomial in general sense, the sum of power functions. Okay, right? And then you know how to evaluate the integral of each power function. So it's going to be 1 plus 3, 1 times x squared, 3 times 1 times x squared plus x squared and cube. Okay, so this is a function of the exponent. Then you find the entire derivative of each of them, 3x and x cubed and 3 over 5x to the fifth and 1 over 7x to the seventh. And this is the entire derivative evaluated in the points. All right, so you will get, no, I admit there's 3 mistakes here, right? It's 1, so it's no. Okay, this is going to be 1 plus 1 plus 3 over 5 plus 1 over 7. Okay. Yeah, you get a fraction. Okay. Yeah, you get a fraction. So it's going to be 2 plus, and here 35, 21 plus 5, 2 plus 26 of 35. 35 multiplied by 2, 70. 70 by 26 is 96. Okay, so this is a fraction. Now, so we also know that the derivative of a tangent x is going to be secant square x, right? And then derivative of secant x is going to secant x and tangent x. Okay. So let's evaluate the integral from 0 to pi over 4 tangent square theta d theta. Tangent square theta d theta. What is tangent square? Tangent theta, right? So you have, this is a theta, this is a y. Tangent theta is only defined between negative pi over 2 and positive pi over 2. When you square it, just square it. Okay. So so if it's 0, it's still 0. Okay, let's assume that this is going to be tangent square theta, and from 0 to pi over 2. So I'm talking about this area. All right, how can I find the entire derivative of this function? You see, tangent square theta, 1 plus tangent square theta is secant square theta. So when you see the tangent square theta, you can change it to the secant square theta, okay? So it's going to be secant square theta minus 1 d theta. Now, how can I find the entire derivative of this? I know secant square theta, the entire derivative of tangent theta, right? So tangent theta and minus theta, okay? Because the derivative of theta is going to be 1. Derivative tangent theta is going to be secant square theta. So then you evaluate it to in the point, you get tangent pi over 4 minus pi over 4 minus 0, tangent 0 minus 0. right? So the second part is 0, tangent 0 is 0. So the first part, tangent pi over 4 is 1. So 1 minus pi over 4, which is positive number. How about sine 2 theta and sine theta, d theta? Well, the only way you can evaluate this integral is to simplify the functions 2 sine theta, cosine theta, here sine theta. And you see that sine theta is gone. You only get twice of cosine theta d theta. And how can I get a cosine theta? So derivative of sine theta is going to be cosine theta, right? So it's going to be sine theta plus constant. Right? So let's go back to the fundamental theory of calculus. So if f prime x equals theta of x, right? Right? I know the integral of this function is going to be capital F of x. But we can also express in this form, integral of capital Fx dx is going to be the difference of the antiderivative between the points. So then you don't need that, yeah. So the derivative, the integral of the derivative will be that. Will be this, right? In other words, if you use a general indefinite integral, then this is just capital Fx plus c. Okay. So something like the derivative and the integral that cancel out each other. Right? They cancel out each other, right? Yeah. Right? So the integral of k plus 1 x to the k dx, right? This is the integral of x k plus 1 prime dx. That's going to be x plus 1 plus cos. All right, now, what's the meaning of this integral? Okay, we know you have a quantity, right? You have a quantity f of x. That's a quantity, right? Some quantity depends on x. So f prime x is going to be the rate of change. Okay, the derivative. So the rate of change, if we integrate, okay, so this integral is going to be the rate of change. Okay, the rate of change integrate is going to be fb minus fa. So that is called the net change. And similarly, if you if s is if the position function at the time t. Okay, so you have a moving object. Here's 0, here's 1, here's 2, right? Somewhere here s of t at the time t. Right? So the derivative is just the velocity, okay, at a time t. So the integral, if t is the integral, this is the total velocity, right? Okay. Total velocity is going to be the difference of this superposition function. So this is called the displacement, right? During this time t. Okay. So the integral of the velocity, the total velocity, in other words, gives you the information as the moving object, the displacement, the initial location, the final location minus the initial location. Okay, this can be back forward, back forward, back forward. It's right, and maybe here t equals a, and here t equals b. So the distance it travels just sb minus sa. Okay, but could be the velocity could be negative, could be positive. Positively, it moves forward. Back negative, it moves backward, and back forward, you know. Then you just look at the initial position and the final position, and you take the difference. Okay, this is what this is the term on the right hand side. The term on the left hand side, at any given time t, you have velocity. So integral velocity is the total value of the velocity. Okay, so the velocity, total velocity is going to be this formula tells you is going to be the net changes in position. So actually, the distance it travels, essentially. It could be back to the original point. Okay. All right. So we know we are given the velocity function. Okay. And this is in meter per second. Okay. We want to do something, right? Find the displacement of the particle during the time period. This is from 1 to 4. Right. So you have to understand yeah, this is the only problem we've been. Yeah, this is the only question, yeah, we have to do. Okay. So find the displacement. So you have to step one, how to do the problem. You just needed to write that down. This is the displacement, right? It's going to be the integral from 1 to 4 s prime t dt. And that is going to be just a velocity, right? And then you just need to evaluate the velocity function. And that gives you the displacement during the time interval, okay? So you find the antiderivative. Okay, evaluate the 200 points. All right, so it's going to be 1/3, be careful, right? The computation. Minus 1/3, minus 1/2, minus 6. Okay, you have to simplify it. And let's see what we can get. Okay, it's going to be 64 over 3 minus 16 divided by 2, 8, and the 24. Okay, minus 1/3 plus 1/2 plus 6. Anyway, I simplified it to the 0.9/2. So which is negative? Negative means the displacement is negative, means the ending point is on the left hand side of the starting point. If you go forward, the displacement will be positive. So somewhere the velocity must be negative. It's possible because t squared minus t minus 6 could be negative for t between 1 and 4. Otherwise, you're not going to get the negative displacement. Sorry. Okay. Let's try to figure it out the entire. We already studied the chain rule, right? So sine 2x dx. Okay. Integral sine 2x of dx. It's not going to be just cosine x. So what we do is we do the guess and try. We look at the derivative of cosine x, which is negative sine x, right? Okay. So how about cosine kx? When you differentiate, you get negative k sine kx. Okay. So it's you differentiate, you create, differentiate the kx, you get k. So you can modify, you will get negative kx minus k, the derivative of that is going to be sine kx. Okay. So my integral of sine 2x dx is going to be, this is the antiderivative. It's going to be negative 2 cosine 2x plus constant. All right. How about this? Evaluate the integral of this function. Well, it's a square. So first thing you have to do is to multiply this out. Okay, that's what you got. And then this is it's sum of power functions. You can also write in this form. So the antiderivative of this will be that, and plus negative 2 plus 1 x to the negative 2 plus 1, and plus 2x plus constant. Okay, so you will simplify. So I'm going to ask you to do the following problem. Evaluate the integral of this function. It's a 2 minus x dx. So that the picture looks like that. Okay, it's 2, 0. Find the area of that region. Okay. Yeah, please do it. Okay, you have to, again, you have to express the sum of power function. Otherwise, you cannot evaluate. At this moment, we don't have any other truth. So you multiply this out and the square of x, right? So square of x can be written as a power function. It's 1 plus 1/2 3/2. Then you apply the formula for the integral power function. So it's going to be 2 times 1 plus 1/2 x to the 1/2 plus 1. And then 3/2 plus 1 x to 3/2 plus 1 and apply constant. Then you simplify, right? So you will get 4/3 x to the 3/2 minus 2/5 x to the 5/2 and the plus constant. So far, if we are able to convert the function to simplify the function to the sum of power functions, you just find the antiderivative for each power function, then add them together. Use the same combination, then you get an antiderivative. That's it. Okay, and we also mentioned briefly it's like sine, cosine. You know, we know this is a derivative, so you can find the antiderivative of sine x, cosine x, secant square x. Those are the examples I did, and